And so in this last video, we'll derive our sum to product and product to sum identities. So let's review, or let's remember, our cosine of the sum and difference formulas. We had the cosine of the difference of beta minus alpha as being cosine of beta cosine of alpha plus sine of beta sine of alpha. The cosine of beta plus alpha gave us cosine of beta cosine of alpha minus sine of beta sine of alpha. And so if we take those two identities and add them together, then the sine of betas and sine of alphas will cancel out, leaving us with cosine of beta minus alpha plus cosine of beta plus alpha as being 2 times the cosine of beta cosine of alpha. If we divide both sides by 2, we obtain our first product to sum formula. Okay, so now if we come back to the cosine of beta minus cosine of alpha, cosine of beta, cosine of beta plus alpha, instead of adding the two identities together, if we subtract the two identities, now the cosine of beta cosine of alpha will cancel out with the cosine of beta cosine of alpha, and that will leave us with the cosine of beta minus alpha minus the cosine of beta plus alpha as 2 sine of beta sine of alpha. If we divide both sides by 2, then we obtain our second product to sum formula. So the product of the sine of beta times the sine of alpha is going to be 1/2 of the cosine of beta minus alpha minus the cosine of beta plus alpha. Now for the sine of the sum and difference, we have the sine of beta plus alpha as being sine of beta cosine of alpha plus cosine of beta sine of alpha. The sine of the difference of beta minus alpha is the sine of beta cosine of alpha minus cosine of beta sine of alpha. Now you can probably guess at this point we use the same trick of adding or subtracting the equations. Well, if we add these two equations together, our cosine of beta sine of alpha will cancel out, and we will be left with sine of beta plus alpha plus sine of beta minus alpha is 2 sine of beta cosine of alpha. Once again, dividing both sides by 2, we end up with our last product to sum formula, as in sine of beta times the cosine of alpha is going to be 1/2 sine of beta plus alpha plus sine of beta minus alpha. Now if we want to go back the other direction, so if we want to go from the product to the sum, or if we want to go from the sum back to the product, we start with our product to sum formulas. So the sine of beta cosine of alpha is going to be 1/2 sine of beta plus alpha plus sine of beta minus alpha. If we do a substitution and let beta equal theta plus phi over 2 and alpha equal theta minus phi over 2, then if we add together beta plus alpha, we have sine of phi plus theta over 2 plus theta minus phi over 2. Well, our phi over 2's cancel out, and we're left with just theta. If we subtract, then we have beta minus alpha as being theta plus phi over 2 minus theta minus phi over 2. Well, now our theta over 2's cancel out, and we're left with just phi. So if we take these two substitutions and plug them back into our product to sum formula, we obtain the sine of theta plus phi over 2, and the cosine of theta minus phi over 2 is equal to 1/2 sine of theta plus sine of phi. Or if we move the 2 over to the other side, then we have sine of theta plus sine of phi is equal to 2 times the sine of theta plus phi over 2 cosine of theta minus phi over 2. So now we're assuming that we're starting with the sum of two trigonometric functions, and that becomes the product. Okay. If we replace phi with minus phi, so use our odd and even identities, so that sine of theta plus phi, sine of theta plus sine of minus phi, so we make that substitution. Then we have our odd property of sine. So this becomes sine of theta minus sine of phi is being 2 sine of theta minus phi over 2 and theta plus phi over 2. Okay. So if we do the same substitution as we did before with our product to sum formula, then we have the sine of theta plus phi over 2 times the sine of theta minus phi over 2 is going to be 1/2 cosine of phi minus cosine of theta. If we move the 2 over to the other side, then we have our third sum to product formula, so that the cosine of phi minus the cosine of theta is equal to 2 sine of theta plus phi over 2 times the sine of theta minus phi over 2. So for the third product to sum formula, we have the cosine of theta plus phi over 2, cosine of theta minus phi over 2 is equal to 1/2 cosine of phi plus cosine of theta. We're moving the 2 over, gives us cosine of phi plus cosine of theta is equal to 2 cosine of theta plus phi over 2 times the cosine of theta minus phi over 2. And so, kind of putting these all together, our sum to product formulas look like the cosine of phi minus the cosine of theta is going to be 2 sine of theta plus phi over 2 sine of theta minus phi over 2. The cosine of phi plus cosine of theta will be 2 cosine of theta plus phi over 2 cosine of theta minus phi over 2. The sine of phi plus the sine of theta is the 2 sine theta plus phi over 2 cosine of theta minus phi over 2. And finally, our sine of phi minus the sine of theta will be 2 times the sine of phi minus theta over 2 cosine of phi plus theta over 2. So what this diagram represents is all of the derivations that we have made up to this point. So the arrow being from where we start to the derivation that we made. Starting here in the center with the cosine of beta minus alpha, we were able to derive the sine of beta plus alpha. We were able to derive the cosine of minus alpha. We were able to derive the cosine of pi over 2 minus alpha, which in turn led to the sine of pi over 2 minus alpha. These two together gave us, along with cosine of beta minus alpha, gave us the sine of beta plus alpha. The sine of beta plus alpha then implied that we had the sine of alpha, sine of 2 alpha. We had the cosine of alpha, sine of alpha cosine of beta, along with sine of beta minus alpha gave us sine of alpha cosine of beta. And so if you just imagine starting at one node in this graph, then we have all of these inferences to all of the other places where we could go in our derivation. So it's kind of an amazing thing. If you wanted to derive all of the trig identities that we've used up to this point, then the small core group that we need to start with are our fundamental identities along with cosine of beta minus alpha, and we can obtain all of the other trigonometric identities.